So hello, welcome to this webinar. My name is Laura Denale from Euronovia, and we are the partner responsible for the communication and dissemination activities of the SCORE project. So this webinar is the fourth episode of the SCORE webinar series that we are organizing on average every 2 months. And it is dedicated to present how the SCORE project is collecting, managing, and sharing the data used and generated by the partners within the project. So this is the agenda for today. Please note that this webinar is being recorded and that it will be made available on the SCORE YouTube channel and on social media. Now, before giving the floor to the first speaker, I would like to invite you to open the slido.com website and enter the code that you see here on this slide. So that you'll be able to join our live Q&A session and answer the 3 short questions we have prepared for you. While you open the Slido, just a few words maybe on SCORE. SCORE is a European Horizon 2020 project led by the Atlantic Technological University of Sligo in Ireland. The main objective of SCORE is to design, implement, and evaluate a novel coastal city living lab framework for 10 coastal cities that are part of the project, integrating ecosystem-based approaches with smart technologies to enhance climate change adaptation and resilience. So now, I don't know how many people we have on Slido for the moment, but maybe I can start with the first question. So just to get to know you better, we would like to know which country do you live in. We'll wait a bit for people to join and to write their reply, their answer. So for the moment, we have Ireland and Italy. Portugal, United States, France, Netherlands, Spain. So many different places. For those of you who arrived late, you can join the Slido session. You have the number here on this slide, on slido.com. So for the time being, Italy wins, but we have several countries represented at the webinar, so that's great. I think we can go to the second question. We would like to know if you have any previous experience with digital platforms for data collection and sharing in scientific research projects. Yes, as a developer, yes, as a user, or no. Okay, so nobody is a developer for the time being. Yes, 1. Most people are users, but a lot of people also with no experience with digital platforms. So you will learn more during the webinar. Okay, and last one, do you know what fair data management is? Not really, so no, or I'm not sure. So maybe Luca, you will need to explain briefly what fair data management is later during your presentation. Okay, great. Thank you very much for your participation. So now maybe, yeah, I can give the floor to Filippo Giannetti, which is from the University of Pisa. And he's a professor of telecommunications at the Department of Information Engineering. And his role within SCORE is to lead the Work Package 5, which is dedicated to data management and also to the development of the SCORE ICT platform that we are presenting today. Filippo, the floor is yours. You are muted.
You're still muted, Filippo.
Filippo, you're still muted, yeah.
Okay, here we are. Okay,
yes.
Thanks, Laura, for your presentation. Sorry for this inconvenience. This is a brief introduction of this webinar, which will present the framework within the platform was developed. The platform presented here was developed within the SCORE project, and it will be presented as a case study for platforms for collection and sharing of data in scientific research activities, so especially dealing with environmental problems. Okay. So the work package I am leading and is aimed at development and management of a platform. The activities carried out in cooperation with other partners that are Tero from Greece and CNR from Italy. The purpose of the platform is to collect and share data within the project community, that is the researchers, but also stakeholders of the city living labs. These are some external participant to the project that related to the authorities and other associations in the cities that participated to the co-design activities envisaged by the SCORE project. The platform will collect past data, that is historical time series data representing what happened in the past in the cities we are studying, the present data, that is real-time data that are collected from sensors deployed in the cities under monitoring, and we also collect data about the future, that is our forecasts of the environmental situation in the cities. Data will be processed by using climate models purposely developed by project partners, and also the outcomes of some real-time processing generated by the digital twins, that is digital simulator of the cities that are aimed at providing near future information, that is early warnings that related to dangers in case of flooding or extreme weather events. And also long-term forecasts will be produced, evaluating the impact of climate change and socio-economic risks, depending on the use of EBA. EBA are ecosystem-based approach, or that is, are interventions based on a nature-based solution, that is reforestation, planting of trees, digging canals, or putting sand on the shores and so on. So the goal is to show the benefits by obtained by using EBA according to our forecast. This diagram, I hope you can see, is a pictorial representation of what I said. That is, we have a flow of data coming from previous project databases that are connected and are fed into the SCORE platform. The SCORE platform also receives data in real time from sensors. Sensors refer to the different cities. Cities are labeled as CCLL, it is Coastal City Living Labs, And also raw data are taken by the project partners that are running offline data processing, fusion, simulation, applying numerical models in order to provide a long-term forecast about the benefits of EBA or the absence of EBA in the cities. Of course, data will be accessed also by world users on a reading-only mode. This presentation will focus on the structure, function, development of the platform. And the first speaker will be Giovanni Allegri, which on behalf of UNIP is the head of the developer team that are building the core platform. And we'll have a contribution by Panagiotis Chatsikameris from Tero, which is the responsible for the development of the sensor interface that is as part of the platform that is taking real-time data from the real world. And finally, Luca Baldini from CNR will illustrate the data management plan, that is the rules that must be applied for a proper data handling, storing, and management. That's all from my side. So I leave the floor to Giovanni for his description of the platform.
Hello, everyone. Just a quick overview of the platform, and I will jump to an online demo right after. So the SCORE ICT Platform has a list of main features, which is being the catalog for spatial datasets and documents and ISO metadata serving the SCORE project. So all the project can use this catalog to share, upload and download data and visualizations built on top of this data. It provides OGC standard services, which are standards for sharing mapping applications and map information between external clients, external applications. So this platform is available to serve all the data to compatible OGC standards clients. On top of the data sets and the documents, the platform supports the creation of maps, dashboards, and geostories, and it offers a complete REST API for developers to interact with the platform. Also, the SCORE partners can use this interface to drive or to manage their own workspace inside the platform to upload data, download, and make their activity.
Sorry, Giovanni.
Yeah.
We cannot see your screen. It's black. We could
really?
see we could see your first slide, but not the second one.
Can you see this one?
No. Maybe you can try to share again.
Strange. Okay. Let's try again. Can you see it?
Yes.
Yes.
Okay. I don't know. So, well, this is what I was saying, and the last point is that every partner can have an account on the platform where he can manage its own workspace, manage the permissions on the data that it shares on the platform, so that the platform grants granular permissions and security to access and share the data on many levels. So it's a secure application. It's based on open source technologies, basically GeoNode, which is composed of very well-known open source libraries and services. And well, I'm not digging into the architecture, but basically you have this big block in the center, which are all the services of the platform. And on the top, you see many different types of clients, desktop and WebGIS clients that can use the services from the platform. And at the bottom, all the providers of the data can be CCLL partners and the other work packages. So what we have a lot of files or services, other services provided by the partners or other third-party sources, remote files that we upload into the platform as datasets which are spatial files, whole spatial information and documents like media, PDF, any kind of file and media file. From these datasets and documents, we can build maps, geostories, dashboards, and other custom applications. I'm not going to tell more here. And afterward, all these maps, dashboard, geostories, but also the documents and the datasets that were uploaded can be served through the OGC service in the REST API, or even be embedded into external websites. So I will go directly online to show you how this platform is. And well, okay. So let me just change the window. Okay, this is the platform. When you enter, when you get on the platform, you will see the list of the latest documents, datasets, images that have been uploaded or created on the platform. This lists everything that is, available. You have permissions to see. Okay, so depending on how the owner of these resources have granted access to the resource, you will be able or not to see it. Okay. So at the moment I'm already logged in, so I have administration permission, so I can do anything. But as a normal user, you will not be able to. You're only able to view and navigate to datasets. There is no way to register at the moment. It's not opened up. You have to ask for an account, and it will be created for you. Quickly, what this platform contains is, as I was saying, datasets, documents, maps, data stories, and dashboards, and specific areas to visualize the datasets related to a certain CCLL or sensors data. So the list of sensors currently registered into the catalog. All this information is available altogether in the homepage with an infinite scroll, but you can filter either from the top bar or from the filter panel. You can filter by categories, by keywords, by owners who created the datetime and spatial extent. So anybody can, with permissions, can upload datasets, documents, or create maps, geostories, and dashboards, or import data from remote services. So when you upload a dataset, I will just make a quick example here. I will upload a very small layer. This is a shapefile containing a zip. Shapefile is a typical format for spatial datasets. And so the upload is very simple. You drag and drop or select the files here. The upload starts, and all the procedure that publishes all these datasets to the backend services and into the catalog is performed, and you are able already to see your datasets on the map with some basic metadata automatically created. And once you have a dataset, you have, as an owner, you have app options to change the styling of this dataset. So how you want to present the dataset, the colors, the type, the graphics, and so on. So creating also thematic maps is very straightforward from this interface because you have visual tools to do that. You can edit the data itself, so the contents of your data that you have uploaded. You can edit the metadata. The metadata is a big topic since we have a lot of fields to make it compliant with ISO metadata. It's not required to have a dataset on the platform, but they will be marked in red if you have mandatory dataset fields for the ISO metadata that haven't been filled. So you can go and fill all the required datasets in terms of attributions, restrictions, and so forth. So you are invited to fill this data, but it's not requirement to have the data on the platform. Depending on the region, you can assign a region, and the region is the way to assign a CCLL. So this is important for those that use this platform for CCLL contents, because this is a way to make these contents available when you click on the related CCLL menu item. So if I assign this to Dublin, when I click Dublin, I will see also these points listed into the Dublin sources. And okay, I will skip to other informations about what can be done. So you can share it, and when I say share it, I mean sharing the link, taking the code to embed this viewer inside an external website, so in your blog, your website, whatever. So this is also for partners for publishing these datasets into their own publishing platforms. They can take this link and put it in their own web page. And here you can select who can do what on your datasets. For public users, if they can view it, by default, you see it's known. It means that by default, when I create a new resource, nobody will be able to see it. Nobody, even registered members, cannot see it. I have to select who can see it. So registered members means those that have an account on the platform. Public, anyone means anybody, okay, even those without an account. And then I can be granular and select the users or the groups that I want to give permissions, specific permissions to. I can print, I can download the data sets. I can download the ISO metadata or the data and the data set. This will download the XML file, ISO standard XML file for the metadata. This will download the dataset in different formats depending on, I mean, if it's a vector, it will have shape files, JSON, JPackages, and so on. For rasters, there will be raster formats. I can create a map from this dataset directly from here. So a map is something more than this. It's a way to represent a stack of layers. So I can put multiple datasets on the same map. I can add datasets to the map. I can add annotations, which is a way to put notes on the map. So like an arrow and know the comment from a point. I can put widgets. Widgets are charts, tables, or text boxes on the map, and publish this map, share it and publish. Also for this, for a map, you have the sharing option. So who can view it, who can, who can access the map and so on. This is true for the maps. This is true also for the other kind of GeoStories and dashboards. I think some dashboards and GeoStories have already been created. So we can see a GeoStory. So like let's see the first one, the Dublin GeoStory. The GeoStory is a way to, a narrative way to share information. So you scroll in a vertical way, you scroll and you show a story with maps, live maps, contents and videos, images like this carousel. So you can, you have immersive visualizations. You can include also contents from external websites and videos and audios. And everything is done with a visual editor, which is quite straightforward to use. I mean, at the beginning, it might be a bit complex, but you can see people have been able to create very nice looking presentations. And these are the notebooks, which can be also taken and put in an external blog post, for example, and it's not only to be seen on the platform itself; they can be seen outside of the platform. On the other side, dashboards are meant to show. There are a few. I don't know how well if they're working, but I think so, yeah. Dashboards are dashboards, so you can include multiple maps with charts, tables, counters, and even you can embed external resources. And yeah, the nice thing is that you can embed the dashboard inside your story. So you can mix them. You can create a dashboard and then put it inside your story. So you can create a data set, a document, create a map, create a dashboard from these data sets and documents, and create a geostories, mixing data sets, the maps, and the dashboards. So there are many ways to combine these resources. It's only creativity, okay? Yeah, the limit is your creativity. Of course, the widgets are limited. I mean, you have bar charts, line charts, so the basic, but I mean, they're already enough for doing nice things, I think. Yeah, I mean, all these behind this, there are a lot of services that let you interact with the datasets from a QGIS or an ArcGIS client, for example. You just have to put the right, for example, if I take a datasets, and I'm not sure if this version has the link visible. Maybe not. Yeah, this one. So if you copy this and put it in your GIS desktop, you can easily navigate. Use this data inside your desktop application. Of course, depending on the permissions that you have, you might only have the WMS service, so you can only have images rendered for these datasets. Or if you have download permissions, you can use WFS services, so you have access to the underlying data from your GIS application. Through the REST API, you can interact with this platform. So you can upload, download, change permissions, edit metadata in a programmatic way. So without using the UI, you can do everything. All the features from the UI and many more are available through the REST API, where you have a token, which is a string that it's given to you once you have an account. And with this token, you can do all the operations on the platform on your behalf. Yeah, okay. I don't know how much time I have. I have no more.
No.
Okay, I think the big picture is this one. Okay, so.
Thank you.
Bye.
We'll see if we have any questions from the audience, and we will reply at the end of the webinar.
Yeah, sure.
Thank you. So now, next speaker is Panagiotis.
Yes, thank you, Laura. Can you see my presentation?
Yeah, perfect.
Good afternoon, everyone. My name is Panagiotis Hadjikamaris, and I am a senior full-stack developer working at Tero, which is one of the many partners of the SCORE project consortium. Today, and in the context of the SCORE project, I will present you the sensor interface system that is responsible for the collection, transformation, and storage of sensor data and metadata generated by both the selected existing official sensor networks and sensors to be deployed during the project. Before we start with the details of the sensor interface, I would like to give you an overview of the requirements and conditions that our system should meet according to the project's goals. First of all, we have to deal with the great heterogeneity of different data formats communication networks and protocols between many applications and systems. Next, we must make sure that the interface complies with standards and specifications relevant to spatial data, such ones set by the Open Geospatial Consortium. Our next requirement is to provide a way to standardize the spatial data collected from various observation networks and sensors. One of the most important conditions to ensure data interoperability following open standards and formats as a key factor for successful knowledge sharing and exchange of information between different systems and applications. Next on the list of requirements is to develop a citizen science platform to facilitate the activities of complementing institutional sensor data with data acquired from a network of low-cost sensors. Last but not least, location matters. And with that, we want to emphasize the significance of the location on sensor data, that it can be used more effectively for analytics, modeling, simulations, and so forth. For example, you can't develop a flood evacuation plan if you don't know the location of the flood event, correct? Communicating the location information and or integrating it with information from other sources is today a necessary requirement for the development of innovative applications for the Internet of Things. Let's continue with the challenges and the difficulties we should overcome in creating our sensor services. First of all, we have to deal with many different data sources providing sensor data in different formats. Our first task is to collect those data from existing official sensor networks and other professional sensors. Some of the disadvantages of such networks are that they are often single-use applications built for a specific purpose. They make use of proprietary and closed architecture systems and specialized user interfaces. Some networks share their data in text files, others in CSV files, Excel files we have seen in JSON format, XMLs, and a few offer an API to give access to their data. So, what is the challenge? All these sources publish their data in uncommon formats and structures. So, we have to find a way first to communicate with the networks, collect and process data in order to transform them in a unified data format and store them in to our database in a standard format as required by the project objectives. So, the second challenge we have is how to collect data from the low-cost sensors that will support the citizen science activities during the SCORE project. Data from different sensor devices should be collected, processed, and stored in a database so that they are available for exchange and use in a standard format. The solution to this: first, the Open Geospatial Consortium Sensor Things API. It is an API standard with the following features. Its data model, first of all, it's an Open Geospatial Consortium, OGC, if you are familiar with the term, standard, that provides an open, geospatial-enabled and unified way to interconnect devices, data, and applications over the web. Its data model is designed based on the OGCI's observation and measurement model. It has two parts, the sensing part, which has to do with the data management and sharing, and the tasking part, which more or less has to do with the control of the device for the Internet of Things. It's a lightweight, RESTful HTTP service. Its data, the data returned from this service are encoded in the very well-known JSON format. It is event-driven using the MQTT protocol, which in short is a lightweight publish-subscribe protocol that allows for messaging between resource-constrained devices. And the SensorThings API enables the data interoperability for the Internet of Things, providing the ability between two or more systems to exchange information and use the information that has been exchanged. And finally, the most important is that it allows location-aware sensing designed for both simple and complex applications. Here you can see the technologies behind the SensorThings API. For the needs of the SCORE project, the implementation of the OGC SensorThings API is based on the Fraunhofer open source SensorThings API server, known as Frost server. The Frost server connects to the database server, which is based on the open source PostgreSQL database management system, with the PostGIS extension enabled. This extension adds support to the database for storing, indexing, and querying geographic data. So now let's take a look at the data model of the SensorThings API service. The SensorThings API data model consists of 8 entities that are all linked to each other. We have the thing, which is a physical or virtual object where a sensor is located. For example, a weather station device or a room. It has a location which describes the physical location of a thing. We have the sensor entity, which describes the sensor that provides the value, for example, a digital thermometer. We have the observed property, which specifies the phenomenon that is being measured by the sensor, for example, the temperature. We have the observation, which is a single measurement value, a single measurement of the thermometer. A data stream which is a collection of all of observations, for example, a time series of thermometer observations. We have the historical location, which provides the times of the current and previous locations of the thing. And finally, the feature of interest, which is the geographic area or location where the observation was made. Here, you can see an example response that we receive from the API when we request information from the base URL of the service. The response on the left is from a public available case study implementation of the SensorThings API, which collects air quality data from sensors around Europe. On the right side, you can see more example requests that we can send to the API in exchange of data. So we have the base URL with the version of the API, and then we can get a collection of a specific entity. We can get the collection of data related to an entity, and we can also get data back from requests from an entity's linked entity data. Some of the great features also of the SensorThings API is that we can tailor the responses according to our needs. We can receive, for example, we can we can specify the maximum number of objects to be returned. we can receive, we can specify that the return objects should be ordered by a specific attribute. For example, the ID, the unique ID of the records in a specific order. We can also, we have the filter parameter, which allows us to get back only those observations or records that their value is, for example, greater than 5. The solution number 2, first solution, the sensor things API. The second solution to our problem is how to collect data. And for this, we have the data collectors. We have developed a series of configurable data collectors for collecting data from existing sensor networks and professional sensors. What are the data collectors? Think of them as web robots, internet robots, bots, if you are familiar with the term. They are individual executable scripts that trigger processes to communicate with different systems and applications and collect sensor data. Can be scheduled to run continuously at different time intervals to collect real-time data with different sampling rates. Can read data with different structures and data formats such as JSON files, TXT files, etc. Can connect to third-party APIs, both public and private, that require some sort of authentication or authorization in order to allow us access to data, and integrate also the process that is responsible for the transformation and publication of the heterogeneous sensor data to the standard format that is supported by the Sensor Things API. And the technology behind the data collectors is the Python programming language. So here are our data collectors waiting to collect data from various sources. And here's how they work. Every data collector is configured to establish connection with a specific network, application, system, API, whatever we want, and request data, and then start to process them. It already knows what format to expect and how to process data that it receives. In most cases, they pull data from the networks, from the different sources, and they process the data, and then they push data, structured, unified, standard format data to the Sensor Things API server. And finally, regarding the case of the citizen science activities, the goal is to develop a scalable solutions for collecting data from different devices and feed them to the Sensor Things API server. The first option is to use the data collectors to pull data at preset time intervals from specific devices, then transform the data, and finally push them to the Sensor Things API in the required format. The second option, for the cases where the device hardware and software allow us to make the appropriate configuration and parameterization, we have the option to push the real-time sensor data directly to the Sensor Things API in a standard format. And finally, the last option involves the user interaction with the application that will be available to citizens so that they can manually upload their datasets to the database. The application will allow the upload not only of data generated from sensors, but also from for other, let's say, field data observations, such as, for example, images taken from personal cameras, smartphones that will help in mapping and monitoring the environmental impact of extreme weather events in the CCLLs. That's all for me, from my side. Thank you very much for your attendance. Laura, the floor is yours.
Yes, thank you. Thank you very much. So now we are a bit late. So Luca, you can start your presentation.
Yeah. Let's try first to share the presentation.
Yes, we can see it.
Okay, I can start. So a few words to introduce myself. My name is Luca Baldini. I am a researcher at the National Research Council of Italy, specifically the Institute of Atmospheric Science and Climate. My expertise is not in information technology, but I am expert in the field of precipitation measurements, especially with remote sensing technique. So I am a data user rather than a developer in the sense of information technology. But in SCORE, I am leading a task on data management, in particular for drafting the data management plan and to implement it. So what a data management plan is? In general, data management plan is a structured way, is a description of a structured way in which the project is going to manage all the data that comes from different sources or are collected or generated or processed within the project. And it should have it should be compliant with a set of rules, and in particular this FAIR principle. That FAIR is an acronym that stands for findable, accessible, interoperable, and reusable. Most of people involved in European project should be a bit familiar with these terms, but in this case, I will recall a bit the meaning of the terms during the presentation. The FAIR principle are implemented to technical solution, but also legal solution, and so on. And most of the principles emphasize the machine actionability of data, so that the idea is that a lot of projects produce data that can be reused by other projects, but without a supervised mode. So machine can search for data, find the data, and process for their purposes. FAIR is not open, but the mantra is that data should be as open as possible and closed as necessary. So open data is more strict as a concept. European Commission provide, and several projects are in charge of providing guidelines, resource for drafting the data management plan documents. The first, some of these documents are contractual deliverable. The first should be released after 6 months, but the data management plan is an evolving document because so many things can happen, especially in a 4-year project like SCORE. So in our case, is updated every 6 months. So the SCORE data management plan was designed to be used by the partners as a reference for apply fair principle to data management, both during the project life, so during this SCORE ICT platform or SIP, and at the end of the project, because projects are requested to leave the data that the data sets that they produce open at the end of the project or during for a future use, and this is done with permanent repositories. So I won't give the details of the SCORE data management plan, because you can access this link where we store all the public deliverables. The data management plan, most of the data management plans are very simple documents, ranging from 6 to 10 pages, and sometimes are very simple. So you already know the sources of data. You have a work package that produce deliverable and journal article, and the data sets associated to article or deliverable should be deposited on permanent repositories, like for example Zenodo, that is the most used. Something that I forgot, the earliest release of data management plan should be within the project proposal. This is more and more requested, not only by European funded projects, because similarly to the budget of the project, so all the project proposals should do an exercise. So think about how many resources are requested to achieve the project goals, and how the proposal should know how to distribute, how to allocate in time and between work packages, and so on. So a similar exercise is requested for data. So are the project aware of the data that they need to achieve the results? If not, are they sure that they will collect all the data that they need, and so on? This is simple for many cases, because many projects work on public data sets, but this is not the case of SCORE. As pointed out by Filippo and Panos and Giovanni as well, there are a lot of sources that should be discovered by the project in the 10 experimental sites that we call coastal city living labs, in which the project apply a co-design, a co-creation approach to discover data and the solutions. So as mentioned Panos in his previous presentation, we have to discover a lot of data from institutional networks that are different each other. So, and this is to collect this data and to make them available to the project is a very difficult and boring task as well. Also, we are going to use a network of citizen science sensors, and this will be decided by let's say in general by the citizens, practically by the living labs. And at the beginning of the project, we had no idea of which sensors were needed and were selected. We know that we have just to focus on a priority of the project, which are flooding, storm surge, coastal erosion, and sea level rising. So at the end, it was clear that that we need something that unify the data management. So it was proposed that this platform that will help the platform, the project during its life cycle. So this is the view of SCORE data management plan. So many sources, some of them unknown at the beginning of the project. There are very heterogeneous work packages dealing with early warning system, networks, EBA's assessment, risk exposure assessment, financial risk, and so on. So they need a lot of different data that will be stored in this platform. To manage the data, we apply as possible the fair management rule. The only exception is that a DOI, so a digital object identifier, should be available, but the platform is not, at least at the moment, is not providing this service. But we can obtain service DOI for external services. So as data are stored here and processed data or sensor data are processed here, they will be checked, inspected before being uploaded to some permanent repositories. This happens with a kind of validation. So I don't want to give details of a data management plan, but just to provide a few key aspects of SCORE management. So I have modified the presentation on the fly to insert some general concept of the fair implementation. So data should be findable, the first F. So data should be discoverable with metadata. It should be identifiable, and in addition to metadata, the DOI is another important tool. So tools, the DOI will be for sure used in after the data will be uploaded to Zenodo or other services. Zenodo actually satisfies most of findability requirements because the data sets are indexed and so can be found by other machine. So provided that records are less than 50 gigabytes, and this should be the case of sensors of SCORE, this is the most natural solution. So accessible. Accessible means that data should be always available and obtainable, but and even if the data is restricted, the metadata should be open. So in this case, the SIP is compliant with the FAIR principle. Of course, not all the data should be open. For example, if data that are processed come from data that are not open. This sometimes is the case of data, for example, from some institutional agencies like space agencies, and also some institutions that work at a local level, and sometimes because they are not fully aware of the licensing implications. Then other restrictions are to parties with, especially parties from industry that sometimes can require confidentiality and proprietary issues. Also, the protection of personal data. We have in SCORE we have a specific deliverable for ethics requirements. So the data management plan should be compliant with these ethic requirements, because we basically we do experiments involving human, even for deciding which kind of ABA and solution we are going to implement, or just to evaluate evaluate the effectiveness of some services and products. So data in this case should follow are not fully open. So data interoperability refers to the way in which the data are formatted and allow other systems to work with your data and so on. For in this case, we we use Inspire and other standard in order to be compliant with interoperability. Then the last one is reusable. Data that are produced should be reused by somebody else. So first, the license should be of the open kind, so should be as open as possible in this case. But in my opinion, this is not enough, because data to be really reusable should be well described. And so in this case, we want to provide a comprehensive description of data. If data are not readable, provide also readable by standard software. We need to provide some software to read the data and describe all the procedures that are followed for creating some data sets. So if people interested in more detail of a fair principle can look at OpenAir website and many other that contains a lot of information about this. So the data management plan should be drafted, updated, but also implemented. So what we do some supervision. So we verify the description of data sources and inspecting also some licensing issues. When partners want to deposit in a permanent repository, we use a prior notice procedure similar to what we do with a journal article, for example, but we inspect for the compliancy with the rule we have set within the data management plan, and also we keep track of the data sets that are stored in repositories. So we have some basic management tool for monitoring the usage of SIP. So this was the last monitoring of Friday, and we have most of the what is stored in SIP are documents more than data sets. But of course, the good factor that the usage is increasing recently because most of the core activity of project are taking ground right now. For another thing is the implementation, also part of the implementation SCORE management plan. Are specific action to ensure the dissemination of SCORE datasets. One of them is the creation of a SCORE community. If people want to search for it, do not digit SCORE, because there are many projects that use the name SCORE, but use a smart control of the climate resilience in the European coastal cities, so that you can find it. and other means to ensure the dissemination of data is to use the data for publication in a data journal. Always provide the DOI to journal and also informal data, informal publication that are used even at a local level. So this is the last slide. So I thank you for the attention.
Thank you, Luca. Okay, so if you have any question, this is the moment. We are very late, so some people already left, but I don't know if would like to ask something to the presenters. Otherwise, I will leave the floor to Filippo for some concluding remarks.
No question? Okay. So we are a bit late, so I'm going quickly to the final conclusions that are mainly related with the future perspectives of this platform. We have 4 components of this platform. The hardware, which is a cloud server owned by the University of Pisa, on which the platform was implemented. So we have a full availability of the hardware, which will be under our management and control. It will be updated regularly as soon as it will be economically possible, but it will ensure long-term maintenance. The software, the platform, as said by Giovanni and Panos, the platform was developed using open source software, which enables easy update, no license, so the software can be freely analyzed and extended, modified, so it ensures debugging and possible upgrades in the near future. The data, Luca explained it very well, which is the fate of the project data to be stored in Zenodo, which is a European-funded permanent repository for long-term storage. So data, the outcomes of our project will be available for a long time to come for researchers. And finally, the platform, which will be accessed available for accessing from researchers, for the scientific community, from local administrations interested in the resilience of the cities against coastal climate, against the climate weather changes. So the platform will be available. Data will be still shared. Will be available in read-only mode, but if other opportunities will arrive to participate to further projects, all the basic assumptions, open software and platform implemented on owned cloud will enable the University of Pisa and his partner to start from a solid structure of a platform which could be enhanced, upgraded for further necessities in the future, for future projects. So we did our best to ensure a very, very long life of the platform.
Thank you. Thank you very much, Filippo.
Back to you.
There is a question.
Yeah, we have received a question. As a developer, how to integrate GeoNode with other third-party tools?
Well, there are several ways to do that. It's through the OGC services, which are standard web services for spatial catalogs, so WMS, WFS, WCS, and through the REST API, if you have credentials to do that. Of course, even without credentials, you have access to the public endpoints to, for example, searching or listing the contents of the catalog. So the integration happens through the interfaces that the application GeoNode, but it means the SCORE platform provides.
Thank you for your answer. I put in the chat a link to a very short evaluation survey, so just 3-4 questions. It will be useful for us to have a feedback also for organizing next webinars. So there are no more questions. So I thank you all the speakers for their very interesting presentations, and I hope to see you again at one of our next webinars.
Okay.